On this one, we're working on these window regulators. This is what winds the windows up and down. And of course, both my driver's side and passenger side are broken. So we're gonna go through how to repair these. Typically, they fail at this pivot pin. And I've got some replacement pivot pins. We're gonna try to make this work again. These aren't perfect, so let's make them perfect. I've already cleaned them up for the most part. Basically, I just put some foam degreaser on them, wire brush, use my power wire wheel on the bench grinder, and basically foaming degreaser and just blow some of that old grease out of there. This one says 663, so June of 63. My car is a 64, and this one says something. It's kind of weird, but this one is not date coded, so this one might be a replacement. The gear teeth are in good shape. And this is the winder splines. This is also in good shape. I think this side's the driver's side, and it probably gets a little bit more wear, but you can't tell from looking at the teeth that this one's really worn out. There's, potentially a little bit of wear there on the top. The thing that usually breaks is this return mechanism. This thing is spring loaded such that it helps wind the window up just due to the weight of the window. So this is a helper spring, a torsion spring, and usually what happens is over the years, it just breaks this pivot off. I can show you on a 911 part. This is what the backside of that pin looks like, and it's just kind of swedged into the steel part. But it's a pot metal, kind of a zinc casting, and this one is present, but it's missing one of the lobes. So this half of the moon is missing, and that's what holds the spring on there. Once that breaks off, it loses all pressure and the spring pretty much falls out. So this is a typical failure, and I ordered some new ones. The replacements are all steel, which is great. So I got these replacement pins from Sierra Madre collection, and there's really 4 different ones to choose from. There's 2 different lengths, and then you can also select if you want this slot to be perpendicular or parallel. This one happens to be the parallel one, but I also ordered a perpendicular one. So this one is perpendicular to the slot. So that goes this way, that one goes this way. And the reason being is that these springs are all slightly different. So when you stack them up, they all have different locations of where they start. So I'm going to pick the spring that works the best for each of these. And because I don't have 2 springs that are identical, I just got 2 different pivots that I can basically test and preload the amount of spring tension that I want. This is where the window connects to the regulator. And so these are spring loaded, and everything here, the rollers and stuff, are working fine. I thought maybe that would be an issue, but these will get oiled up and greased and stuff, but these are all working great on both sides. And the pivots are also nice and tight on this side of the arm. This is an adjustment. This actually gets tightened down, but everything is looking good. The only thing that I found that's a little bit loose is this part right here. There's a slight bit of movement in that rivet. And that's true for both sides. So we can hammer that rivet down a little bit more and maybe tighten that up, because we really don't want that flopping around like that. Both of these pivots are from Sierra Madre, and this one, the spring actually goes in. This one, it does not. The spring will physically not go in there. So this slot has to be modified as it is. And I believe I got the pins that are too long, because there really shouldn't be that much of a gap in there. So I ordered the long ones knowing that I would have to probably modify them, so I can always cut them shorter, but I didn't want to have to weld them longer, if that makes any sense. So this is too long by about, I don't know, 1.5 millimeters right there. You can see how the system moves with its gear. Everything seems nice and smooth. Of course, there's no spring on it yet, but that's the motion. See how the arms going up and down? So let's go ahead and take this pivot out and determine, what shoulder length it should be. so that this can stay nice and tight. Because the problem we're having right now, I got this screw on the back screwed down, and there's just too much motion between these two plates. Of course, it does hold it together, but it's supposed to be clamped tight. This 911 one, which still has the pin in it, is clamped tight. There's no movement in those plates. So this is what we want to try to get to with the steel pivot. So it just falls right out. You can see it's got this diameter, and then it's got a step right here where it coincides with this slot. So this part will go all the way in. It's not that it's too big or anything. It's just that the shoulder between here and here is too big for this thickness. So what we need to do is measure this thickness, and then modify the pin so it's correct. So the height of this thing is 143. So we just need to take 80 thousandths off of this pin in order for this to work. Now I could return this and get the other one from Sierra Madre, but I'm running out of time, and most likely these have to be modified no matter what. So I'm just gonna take my, my tools and make that deeper. Also, I'm not a big fan of the screw holding it together. I'm gonna weld this onto the back because this piece will never break again, and I want this to be a permanent repair. The original thickness on this is 312. So as I'm grinding down, I just don't want to change the width of that. So now it's a lot tighter, but there is still some movement. This cut here was rounded from Sierra Madre anyways. It really should be square. That's great. So it actually goes in this way, but at least now we know it's protruding all the way through. So let's put it together correctly. Doesn't really matter what gears are engaged. Yeah, that's all the way through. And this is way too tall here on this side now. Things are fitting really nice. There's no more wobble in it. I think what my plan is not to use the screw. The screw isn't gonna secure anything. The way the factory did it is they peened this down and just mushroomed it so that it made like a rivet and it made it tight. But because this is never coming apart again, I'm happy to just TIG weld along the side and be done with it. It'll be a tack weld, so if I did need to grind it off because it's too tight or something, I could do that too. But let's just make sure it can still move. So I'm just turning this with my fingers, and it's nice and tight, but it still moves. I can't clamp it the same way, so I'm gonna have to use some vice grips. So yeah, there's just a little fillet weld on each side. And even without grease and stuff in there, I'm getting really good motion on the gear system. So no binding, it's nice and tight. This to me is more controllable than trying to just squash that down. I think the factory used the soft metal because it's easy to clinch it down. But this metal, you'd have to hit it pretty hard in order to mushroom that out so it makes it tight. This will never work itself loose, so I strongly believe this is the best repair method. Now, even though I said I wanted this to be perfect, there's one piece that is potentially missing in this stack up. So in between this plate, which is this kind of rectangular plate, and these pivot arms where the pivot pin goes through, some people believe there should be a washer there. I don't have the washer. I didn't put the washer in. I'm just going to grease this area. It is metal to metal contact, but so are all these other joints. This is metal to metal. This is a bolted joint. This one here is metal to metal. And when I looked at putting a washer in there, it just seemed to me that it was going to push this gear a little further away from the plate, and it's already making contact on this part of the window where the pinion gear is. I didn't put the washer in there. The washer may reduce some friction, but because I was so careful in establishing the height of the pin and making sure that there was just like a 5 or 10 thousandths clearance there before I welded it, I think it's going to be just fine. I don't feel any binding or friction on that. No washer, I think, is okay. But that's the one thing I thought I should mention. I suppose I could have taken this 911 regulator apart, which still has the factory soft pin in it. I think I can see a washer in there. It's not a big one. It's a pretty small diameter, and it doesn't have a lot of thickness to it. I would have had to modify that pin either way. So, like I said, if you have the washer and you want to go ahead and use it, go for it. I noticed this one also makes contact right here, because when you put the washer in it, it moves this gear a little further into this housing. So there's a big scrape line on there. I think it's good either way. I don't know that the washer is going to reduce the friction that much. If I was just to smash it, you're putting a lot more squeeze on it, and I think that's what the washer's there for if it's a peened surface. If it's a welded surface, I don't know that the washer is as important, but if you have it, go ahead and put it in. It's totally up to you. Now this one happens to be the pivot that the spring doesn't fit in. So I'm going to open this up with my grinder. This part that sticks way out, I know the original didn't stick this far out. I'm not sure if that is going to interfere with anything. Okay, here's the window in the regulator, and the wheels are kind of centered in the channel. The window does go over where that pin protrudes. So depending on the angle, it could actually interfere. So I'm going to trim that piece down just to be on the safe side. I don't think it would ever make contact, but at this point, let's just cut it off. And the last thing to tighten up on this before we put the spring in is this pivot right here could improve just a little bit. Like I said before, it's got some movement in it. If I put this on my vise here and hit it with an air hammer, I think that will tighten that up. Okay, so that took all the play out of that. Now it's rock solid. No problem, the whole range of motion on this. Real happy now with the structure of this mechanism. There are no loose spots anywhere. So now let's figure out what spring to put on here to get the correct amount of tension on the window. Okay, after much thought, I think I've figured out the way the spring goes. The loop of the spring, or the horseshoe part of the spring, should point to the ground. I think that's true for both sides, but I've only got one side done so far. So this points down, and there's not a lot of pre-tension on it. Basically, if this is going to point down, it either goes this way or it goes this way. It would have to circle all the way back over to here. That would be 180 degrees of preload. That's probably too much. It's probably never going to get on there. So I've elected this spring, which has only got like, maybe like 1/10 of a turn of preload. That is all it does. And it's best to put the spring on when the window's in the up position, because when you wind it down, it creates more tension. You can see how the spring is getting farther away from its pivot, so it's getting harder and harder to put it on as the window goes down. When the window's in the fully down position, you cannot move the spring. It is fully loaded. So the spring is assisting the weight of the window. And if I did want to increase the tension, I could use these other springs, which are formed quite a bit differently. But what I found is that this one would have to go all the way up to here. That's over 90 degrees of tension. This one would have to go a full 180. So that's why I think the parts companies offer these pivots in either parallel or perpendicular. In this case, the perpendicular one is perfect for this particular spring. If we get to the other window regulator, I think the parallel is going to be more appropriate for these two springs, because I physically couldn't even get it on there. If you have the old parts, which I didn't, you can just match it up. But the truth is, the springs, being that they're 60 years old now, have probably taken a set, and you might prefer to use the perpendicular like I have, because it takes up some of that weakness of the spring. The spring constant is still good. It just, the starting and ending points of these loops might be slightly different. Now, I did measure the weight of the windows, about 5.5 pounds. So in an ideal situation, the force on the window would be equal to the weight of the window, right? So you can kind of get an estimate of what that force is. If you put it at the top of its travel with the window in the up position, there's a little bit of play in the gears here. So when I hold this part firm, I can sense when the spring is pushing or pulling against the gear. So at this point, it's minimal force. It kind of springs back on its own. But when it's in the midpoint of the travel, or when it's in the down position, it does create more force. So I tried to estimate what that is. I have a little luggage scale here, and it measures pounds. So basically, if I put this here on where the window goes, and this is all done upside down because this thing only pulls. So if I put this down on the table, and I hold this part that attaches to the door frame, I can get a little bit of a read on when the slack is taking out of the gear train. You can see the gear is just moving ever so slightly, and that's the spring in action right there. See how it bounces back? So that force right there when it bounces, that force is 5.5 pounds, which is exactly the weight of the window. Now the force will be a little bit less when it's in the up position. So at the up position, put it all the way to the top there. Make sure there's still a little bit of play in the gears there, because we want to feel that spring pressure. So now I'm holding it and I'm pulling on it here. So we hold this part firm, and that's the spring pressure right there. That's only 3.5 pounds. So in order to just, you can kind of get a sense for it like this. So let's try it with it in the fully down position, because that should generate the most force. Might be a little bit easier to see it too. £8 pounds. 8 pounds just to cause the spring to move. So roughly speaking, the spring is doing the best job it can. It's never going to be perfect. It's not going to be able to do an even 5.5 pounds on top and bottom. So I think typically when you start to roll your window up, it's going to feel a little bit less effort. And then when you get to the top, it gets a little bit harder. I think that's normal. Of course, we'll find out once it gets in the car. But in my opinion, this regulator is fully done. It just needs to get painted. So I'm gonna put a light coat of paint on it. I don't think the factory ever painted these. I think they maybe got a little bit of overspray on them. I'm gonna grease a few of the areas before I paint it because this is where I don't want paint to stick in some of these crucial pivots. So we'll just put a light coat of grease on this. These have had time to dry outside. So now we can kind of, clear the paint in the areas where it really shouldn't be. We don't need paint right here. So this is not fully cured. We can just kind of delete the paint in the spots where it does move. Now we'll load some more grease in this thing and put it in the car. We can pack a bunch of grease into this cavity and just make sure all these teeth have grease on them. And push that spring down and make sure we get some grease in the wheels. And I'm just gonna put some oil inside this, a little bit of oil on these guys. Installing the regulators in the door isn't that tricky. It basically just bolts in through this big hole. The only tricky part is it has some low profile M6 bolts. And I'm using the thin wavy washers on those just to make sure there's plenty of clearance for the door card. We don't want any bulges in the door card. Okay, these are the low profile screws. That is nice and flush with the indentations here in the door itself, the door frame. And I think it just gives you a little bit more clearance, especially when the door card is here with the winder. So I did use the thin washers there. Regular screws can be used up here. I installed this earlier. I'll show you guys that here now. To open the door, you pull down that moves that pin right there. And then of course to lock it, you just push it up and it stays. These handles are oriented, I think, correct. I think this is supposed to point forward. When the window's all the way up, we can position this so that it's also, pointing forward so that the two things are parallel. It's kind of easy to reach. It does get close to the window frame right here, but that's okay because this piece is pretty flexible and the window will dictate its position. So it has the channels in the window frame and the window can only go up and down in those areas. This gets attached to the window and I think it's gonna pull it in. If not, we may have to, do some massaging, maybe even shim this bracket away from the frame a little bit. It's an old door, it's been through a lot, so we'll definitely make sure that the window and the regulator are lined up without any binding. But so far, so good. We've got the newly plated latch that's installed. I did get the correct screws. There's one of them right there, but those are the other ones. They're basically just the same thing, just slotted. Next thing to install is the big window frame, and they're both done with the wind wing and everything. They're basically just sitting in the dining room right now, waiting to be installed, but I'm missing the flexible channel that kind of goes from the top down on the rear of the door. It just hasn't come in yet, but as soon as that comes in, I got the glass ready. It should just, drop in. There's tons of fiddling and adjustments to do here on the door bottom. Lots of little brackets and hardware, but I got all that stuff prepped. So as soon as that comes in, I'll get that door frame in. I did do another video on the soundproofing and waterproofing of this door. I put seam sealer basically in every seam, and there's some modern sound deadening on the skin. Made a big difference to the sound quality. So I'll do a separate video on that one. I will see you guys next week. Thanks for watching.